Welcome to this overview of PASCAM WoodWorks and PASCAM 3D VAR. Before we move into 3D wood batch, let's begin with typical modifications and processes. Let's start with the PASCAM quick joint. This is usually a small face, big face construction technique or joinery. We start by selecting the small face or the edge face and the corresponding part it will mate to. This edge face becomes the driving part such that the modification on the large face is driven by the location of the edge face. The insertion vertex and the surface for the modification is selectable from the graphics area. The actual type of modification is stored in a SQL database, which also stores the CNC data. Once selected, PASCAM applies the modification, and it's automatically applied to both parts. This process is typically driven by an equation which is applied at insertion, ensuring the modified parts are fully parametric. If we open the variable manager and change the dimensions of the part, we can see the behavior of the part and how the modification is controlled by the part size. As noted before, the modification is driven by the location of the joining part. Once rebuilt, the modification on the gable is once again aligned with the shelf. Let's reopen the variable manager and return the part to its original value. We can also see the start and the end values for the dowel on both the side left and the top, so we can always verify they remain aligned and equal. If we look at the equations, we can see the number of instances of the dowels and cams is driven by the width of the part, and the spacing of the dowels and cams is also predicated by the width and the number of instances. Let's continue with adding modification processes. Next, we'll add the adjustable shelf with the Rafex connection. This proceeds along the same lines as the fixed shelf, the shelf holes being driven by the shelf location. Next, we will add some hardware modifications. This is similar to the quick joint functionality. We will add the drilling pattern for 50 centimeter Accuride drawer slides, which are the drawer slides included in our model. The Accuride slides have two drilling patterns we can choose from: the drilling pattern for the drawer box members or the drilling pattern for the left and right side. In this case, we already have the sides attached to the drawer box, so we will simply select the left and right sides. PASCAM applies the modification to both the left and right sides, and as with the quick joints, the modification is driven by the location of their accurate slides. The hinge and mounting plates are handled in a similar manner. There's a selection for the hinge boss and knock-in dowels with the mounting plate holes, the hinge boss and the mounting plate holes, the hinge boss only, or simply just the mounting plate holes. In this case, we'll select the hinge boss with the dowels with the mounting plate drilling pattern. The overview here is designed to give the user an overall understanding of the functionality and the technology behind PASCAM WoodWorks. It is intended to show the typical construction techniques and various methods employed in the woodworking industry. Though not all shops employ the same joinery techniques, it can be seen that through the use of PASCAM WoodWorks and SOLIDWORKS, practically any construction methodology can be defined, not only once but reused over and over. PASCAM stores all modifications with all attendant CNC data in an SQL database. Moreover, any modification can be used through a simple drag and drop. Parts and assemblies can also be stored in this database. The preceding examples were provided to give the user an understanding of the next part of this video, where we will build what is commonly referred to as a master model. But first, a quick look at the power of PASCAM CNC, without a doubt the most powerful woodworking cam available in the world today. As shown, this gable represents the last positioning of the fixed shelf drilling pattern, the adjustable shelf drilling pattern, the mounting plate drilling pattern, and the accurate slide holes. Let's quickly look at the simulation. We can apply an outside contour from simply selecting a saved strategy. In this case, a G42, which is the tool parameters, the lead in, lead out, and all we need is the geometry and the start. This toolpath also has contour splitting, which will allow it to start in the middle of the longest side. Before we start the simulation, let's delete the drillings and reapply them, just to show how easily PASCAM handles vertical and horizontal boring and optimizes the drilling for CNC woodworking machines with drill banks. Here we have a typical cabinet with open shelves and 2 lower doors. This cabinet has been constructed with the exact techniques we have seen earlier. In addition to everything we have seen previously, we have introduced a new feature called the Condition Manager. Through the use of the Condition Manager, we can construct a master model, though in this case is relegated to just turning on and off drawers and doors. All the equations we have seen in the previous model exist in this model as well. In addition to quick joints and the hardware insertion, there are many other features that involve the use of reference dimensions to drive the location of the parts in the assembly. This we see here. The position of the fixed shelf is a SOLIDWORKS reference dimension, driving the location of the fixed shelf, which in turn drives the drawer sizes, the lock mechanism, and the routing that houses the lock bar. If we open the side right, we can see the parametric nature of the routing. In addition, we notice the drilling for the mounting plates is suppressed. This is the result of the Condition Manager, which has a cabinet configured for 2 drawers, and by so doing has suppressed the CNC data for the hinge plate drilling pattern. Let's have a look inside the Variable Manager and see just how this cabinet is constructed with respect to the conditions and equations that are driving our model. As we look at the various mate dimensions indicated by the paperclip, we can surmise that the cabinet width is a distance mate between the outside of the side left and the outside of the side right. If we look above the cabinet width, at the inside cabinet width, we can tell it is a SOLIDWORKS reference dimension by the loft symbol, and we can determine the sides of a thickness of 25 millimeters. Since this is a driven dimension, we can use this as a driving dimension for the drawer slide width, also known as the ICW, the inside cabinet width. From there we can invoke equations to drive all the features of the drawer. Lastly, we have 2 sketches called Include 2 Lower Drawers and Open Shelf. In the turn box, we see the numbers 1 and 2. Selecting 1 will turn the drawers on, while 2 will turn the feature off. Let's select 2 and turn the drawers off. Through use of the Condition Manager, this will also turn off the lock bar routing as well as the drilling pattern for the drawer slides. In turn, it will turn on the 2 lower doors with handles and mounting plate drilling patterns. I keep having to move the Variable Manager to the other monitor in order to see the model being rebuilt. Ordinarily, it's permanently on the other monitor, so please forgive this irritation. Let's have a look at the Condition Manager. The Condition Manager allows us to have control of every variable, feature, part, in effect everything in the model. If we look at the left lower door, it shows Include 2 lower drawers equal to 2. Set defaults. The Condition Manager allows us to set to true or false, on or off, every part of our model or assembly. By turning features off or on, this also suppresses or unsuppresses any relevant CNC data. And a quick look at all the variables in the current model. Now that we've had a look at the condition manager, we can look in the variable manager to test whether all the variables are functioning as predicted. We can change the depth of the cabinet to see the changes in the model. Of course, it would also be possible to change the depth of the cabinet with the drawers turned on, and have the condition manager insert the appropriate depth drawer. In the master model, all relevant drawer depth sizes would be included, thus making this easy to switch sizes. The model shows us that the correct number of dowels and cams are inserted, and the shelf is also updated accordingly. Let's set the model back to its original value. At this point, we will turn on the upper doors to complete the conversion of the model from 2 drawers with an open shelf to a cabinet with upper and lower doors. This completes the model to the point where it can be saved as a PASCAM WoodWorks file, ready to be used in 3D VAR WoodBatch. This will allow configurations to be built inside PASCAM 3D VAR without the need for SOLIDWORKS, insofar as model data as a PASCAM WoodWorks file. This is then generated by SOLIDWORKS through the use of WoodBatch. When saving a PASCAM WoodWorks file, we are presented with all the variables from both the condition manager and the variable manager. PASCAM presents us with both private and public variables. We select which conditions and variables depending on how we built our model. For the purposes of this video, I will select the variables and conditions we have been using all along. In addition, I will save screenshots to be used in 3D VAR to identify which variables we wish to change inside 3D VAR and have them rebuilt in SOLIDWORKS. Here we are at 3D VAR, ready to input the variables to generate our model. We can see from the images what is represented in the dialog box and what 3D VAR expects of us. I will enter the variables needed to build a cabinet with lower drawers and upper doors and save the file as a new PASCAM WoodWorks file. It can be easily seen that this could be used as an order entry form, and it is possible to have 3D VAR build a model from an ERP system. The ERP system simply needs to provide a simple XML file configured with the necessary variables. Rather than save this file to a directory, I will simply save it in the trigger. This is where WoodBatch looks for the PWW PPS files when SOLIDWORKS starts up. Any file sitting in the trigger will automatically rebuild inside SOLIDWORKS and save the assembly before moving on to the next. In this manner, 3D VAR can generate the PASCAM WoodWorks files and then add them to the trigger without the need for trained SOLIDWORKS constructors. Now it's simply a matter of starting SOLIDWORKS and have WoodBatch build the SOLIDWORKS assembly from the 3D VAR variables. The file opens in its last saved state and is rebuilt from the contents of the PWW PPS file. We can see SOLIDWORKS build the assembly from the 3D VAR configuration, turning on both features, parts, and subassemblies. One of the unique features of PASCAM WoodWorks is the Save in Project, or Save as Commission. Essentially what this does is save the parts and assemblies as unique files, breaking the external references to the seed part. This is what we are looking at here. This was originally the modern series cabinet and saved as commission. PASCAM's number generator generated new part numbers for each part. This enabled us to save each generated configuration as separate models to save on the database, so as not having to rely on 3D-VAR to generate new models if one should choose this approach. Here we have the assembly just generated and the assembly it was created from. Looking at the variable manager, one can see different values for each assembly, and each assembly is wholly independent. Thank you for taking the time to view this video. We appreciate your patience.